Okay, in this video we are going to have a quick look at the Reyax LoRa modules. I have one mounted on my breadboard. This is the RYLR 890 and I have it connected up to an FTDI module. Now I bought a couple of these modules to compare them to the modules I've been using, made by Ebyte, that's the E32 series, and they're quite different. The Reyax module is a low power module. The RF output is plus 15 dBm, which is about 32 milliwatts, and it only draws 45 milliamps on transmit. And you can configure the spreading factor and the bandwidth and the coding rate independently, as opposed to the E32 where you just set your over-the-air data rate and it picks the best combination of spreading factor, bandwidth, and coding rate. So they're quite different, and the E32 module is transparent. When you send ASCII character codes into the UART, it sends them, it transmits them automatically as long as there's characters in the buffer. And on the Reyax, you have to use the AT command. So use the AT send command, and then in that send command string, you put your data. So it's a little bit different. I have two of them hooked up. I have a transmit and a receive, and I'm using a serial terminal program on my transmit called RealTerm, where I could actually enter the AT send string into a text box and then hit a button and it'll send it all at once with a carriage return and line feed. So I'll send the string hello world, and I have a receiver on. You could actually hear it, and you can see the LEDs on the FTDI modules. So I'm sending the string hello world using RealTerm, a serial terminal program. Okay, I have two serial terminal programs running on my computer, and the first one is RealTerm, and it's running on the bottom of the screen, and the second one is TerraTerm, it's running on the top of the screen. Now RealTerm is connected to my transmitting LoRa module, and TerraTerm on the top screen is connected to my receiving LoRa module. So if you look on the bottom, you can see I could send AT strings. I just put them into a text box, and I could hit send ASCII button, and it will send that string, and it will put a carriage return and line feed at the end of that string. So the first thing I'm going to do, I'm going to load the factory configuration. You can see AT plus factory, so I'll send that, and you can see I get an answer back, factory, so that means it's been set, so I'm set to my factory defaults. Now if I send AT plus send equals 0, that's my address ID, 11 is how many characters in my data, and then hello world is my data, and there's 11 characters in hello world. So if I send that string with a carriage return line feed at the end, you'll hear it transmit, and at the top you see I got it receive. Receive equals 0, that's our address ID. 11 is how many characters in the data, and we get our data hello world. And then we have an RSSI value, minus 38 dBm, and then we have a signal to noise ratio of 40. So I'll send it again, and I have a receiver set up, and I can actually hear the data bursts, so I'll send it again. You can see in the bottom screen the AT send command with my hello world, and on the top screen is my receiving screen. And you can hear the data being sent. That's the hello world packet. So all you need is just two serial terminal programs, and you could actually get the two LoRa modules up and running and talk to them back and forth. Okay, I've captured a data packet on the output of the Reyax LoRa module. So this is the hello world packet that I've sent, and I captured it on my scope. So you can see here's the data, and at the very end you can see the squelch tail of the radio. So I could expand that, and we could have a look at the very beginning, and we could see the preamble. You can see the up chirps. That's the preamble that's telling all the other LoRa modules that data is coming. And then there's two down chirps. You can see the two down chirps here. That's the sync. Now after the preamble and the sync, then we get our data. So the rest of this is all data, all the way to the very end, until we get our squelch tail. And that's the hello world packet that I sent from one LoRa module to the other. So there's the end of the packet. That's the squelch tail. So there's our LoRa packet captured on the scope. Okay, here's the schematic diagram of the Reyax LoRa module, which I built on my breadboard. And the LoRa module runs on 3.3 volts, and it gets that power from the FTDI module. So the FTDI module is jumpered for 3.3 volts, and output is fed into pin 1, that's VCC. So there's 6 pins on the module, 1 to 6, looking from the front. Now pin 2 is a reset, and it's pulled high with the pull-up resistor, a 10K pull-up resistor. And if you want, you could put a push-button switch from the reset pin to ground if you want an external reset. I have a capacitor on the VCC to ground, just a little bit of filtering. The TX and RX of the Reyax module feeds into the TX RX of the FTDI module. And then we plug the FTDI module into the USB port of a computer, and we could run a serial terminal program at 115.2K baud. And then we could gain access to the LoRa module. Now if you build 2 of these circuits, you could actually talk back and forth to one another using a serial terminal program. Okay, this LoRa module comes with a helix antenna, and you could use it on your bench for testing. It works out okay, but if you want something a little bit better, if you look on the back, there is some pads, some solder pads, where you could solder on an IPX connector that goes on something like this. You'd solder on right there, then remove the helix antenna, and then you could get a cable, an IPX cable, to SMA. Now you could hook up any kind of antenna that you want, and it will probably work out better than this helix antenna. So that's one option you could do if you want to get a little bit more range out of your LoRa module. Okay, so that was a little introduction to the Reyax LoRa modules. So if you want more information on these modules, go on their website, and you could download their LoRa AT command guide, and they'll give you all information to configure and program your LoRa module.